Hi guys, Gráinne here from Solid Solutions Ireland. So this is what we're going to do today. We're going to do a flow simulation on this part. This is lesson 1 of flow simulation, so it's to get your basics down. So this is an inlet manifold. So on this part we're going to prepare the model for analysis. We're going to set up our flow simulation, apply our boundary conditions, set up our goals, run the analysis, and then do some post-processing on the results. So we have 6 outlets here and 1 inlet. So what we need to do to begin with is to create lids to cover all these inlets and outlets so there's nothing interfering with our flow. So I'm going to go to our Create Lid tool in our Flow Simulations tab. So in your Create Lid tool it even says here you want to select a planar face the openings belong to. I'm going to create a first lid on our inlet here, click the planar face, and it comes up automatically for me. Now I can vary my thickness with my tool on the left hand side here. So if I go 2mm, it's going to edit my preview. You can see it's doing a boss extrude, but it's doing all the work for you rather than you having to do it manually. We're going to do a manual lid next, so I'll show you the work that's involved in that as well. So since the Create Lids tool has come in, it's much better than trying to manually do one. So if I go over to my face here, to do a manual lid I have to go to my assembly, and then I have to go to insert a new part. So I need to create an in context assembly part. So I then have to create a sketch, so I select my planar face I want to create a sketch on. What I'm going to do for this particular part is convert the entities. So if I'm in my convert entities tab, I want to select this whole square here, so I'm going to right click and select tangency, and it should have selected everything. You can see everything in baby blue is selected. I'm going to click yes to convert entities, so you can see my sketch is now made. I then have to do a boss extrude. So when you're doing a lid, you always want to do a mid-plane extrude. So you want to make sure that your part is touching all the surfaces it needs to be a lid. So I'm going to create this boss now. I'm going to show you exactly what happens if I don't do that in a short while. So that part is now created. So at the moment I have this part created, which is called part 38 collector, and we also have a lid created. You'll notice how the lid actually has a knowledgeable name. We're now going to create the rest of our lids using our very simple Create Lids tool. So if I go to my Create Lids tool, I can create the rest of my lids all at once. I just have to click the faces that they belong to. So you're probably going to say, okay, but they're picking up all those bolt holes as well. There's a couple of questions you have to ask yourself here. Are they going to interfere with your flow at all? Are they going to interfere with your simulation? In this case, they're not. If they are going to, you can simply go back and delete them. So they're known as individual lids. You'll notice that this lid is separate to this lid. So we have lid 19 and lid 20 here. So if I even just select these 2 lids, so I'm just going to press Control, select 2 of them and delete. All I have to do is click yes to all. It's perfect. Okay, before I go any further, I'm just going to save. So you saw how easy it was to do the lids using the lid tool rather than using the convert entities tool. The next thing we're going to do is check your geometry. So we've got a very easy to use check geometry feature in our flow simulation tab. This will bring up all the parts in your assembly. So if you don't want to include them, you can uncheck them. I want to check them all for this particular analysis. Because we're using an inlet manifold here, we're going to use an internal analysis, and we're going to check then. So once I click check, it's going to go through all my geometry, and it's already told me geometry is okay. It's perfect. I'm going to X out my geometry. I now want to show you what can go wrong if you do a manual lid. So what I'm going to do is go back and edit this part. So I'm going to right click, edit part, save all. Okay, so I now want to edit my boss or base. So I go to edit feature. I'm going to go and just go blind. and I'll just show you the difference it makes when I go to check my geometry. So even though it is blind and it's supposed to be touching, there may be tiny little gaps in our part. So when I go internal, all my parts are selected and I go check. You'll notice the difference in time it takes for the check geometry to go through. So it's taking longer. Before it just took a second, now it's taking a couple more seconds. I'm just going to leave it run for a moment and then we can go back and go back to our mid extrude, and then we'll move on to our project wizard. So even though there is no visible gaps, what SolidWorks is trying to do is make the extrude touch off the surface it needs to. So SolidWorks is solving these problems for us at the moment. That's why it's taking so long. So you can see it's 78% at the moment. It's now going to go through and try solve it for us, and it's going to come up saying 0 thickness geometry. SolidWorks has solved your problem for you. So here we go, invalid contacts. When I click on them, it will display them, so I can see it's not really joined up properly, but my problems are detected and fixed. For the purpose of this simulation, I just got X out of that, and I'm going to go back and change the part again back to my mid extrude. Okay, so now what we're going to do is we're going to go to our Flow Simulation wizard. So in our Flow Simulation tab, we have a wizard. So I click on the wizard and it will bring me through my project step by step. So if you're doing a number of projects for a part, you can rename them. So I can rename this as manifold pressure, manifold velocity, manifold anything. It makes no difference as long as it's meaningful to you. So when you come back in a couple of months to check it, it is still relevant. For the purpose of this one, I'm just going to call it project 1 and use this configuration and go next. Next is our units. We can go from imperial to SI to USA. For this one, I'm going to use SI. We can also change the unit of measurement of our parameter. So we can go from Kelvin to Celsius to Fahrenheit. This is for everything. For pressure and stress, you can change it. These are just our default ones. I'm just going to go next again. So earlier I said that we'd have an option to exclude the cavities without flow conditions. These are those lids that we don't need to take into account for our analysis. We also mentioned already that it's an internal analysis, and these physical features are not relevant in this particular case. Our reference axis is our x-axis. So for this particular part, our gases that are matter to us are air. So I'm going to double click on air. It will appear in my project fluid. Our flow type, we want it to be laminar and turbulent. There is options to have it either or. Again, in this case, we're just going to use laminar and turbulent. We want our wall to be smooth, so we're using 0 roughness and our adiabatic wall. Again, these parameters are just standard parameters, and for this particular case, I'm just going to go default and next. So these are result resolutions. So this is what matters for your mesh. So in SolidWorks Simulation, we have a mesh that goes around our part. That's how the simulation is then carried out. So as you would imagine, the lower you go, the faster your simulation, but the coarser the mesh, so the less accurate. So the higher you go, the finer the mesh and the more accurate, but your simulation will take much longer. So it depends on what you're aiming for here. I'm going to leave this at 3 and we'll see how we go. And I'm going to go finish. Okay, so you'll now see I have a projects tab for flow simulation analysis in my feature manager tree on my left hand side. So I can rotate, you can see I have a boundary computational domain around my part. You can move that if you like. For this part, it's fine the way it is. I'm now going to insert my boundary conditions. So like with most things on SolidWorks, I'm going to right click and insert boundary conditions. So for your boundary conditions, you need to select the inside face. So I'm going to right click, select other, and select the inside face of this part. I want to figure out the inlet volume flow in this particular part. I then want to set it to 0.05, and I do want the flow parameter to be normal to the face. Of course, I have the option there to put it as swirl or 3D vector. I'm going to click yes. I'm then going to insert all my other boundary conditions on these 6 outlets. These boundary conditions do need to be done separate. For the boundary conditions, I find it easier to select my inside face before selecting my boundary condition. So you can select the inside rather than mess around with it later. For this particular boundary, I want to put a static pressure. I'm going to repeat these steps for my next 5 outlets. There are options to do static pressure, environmental pressure. You can edit your environmental pressure as well. Do be sure to select the inside face, as it has to be the face that will touch the flow rather than other. If you do select the outside face, it will come up with an error and tell you that it's not within the domain. Our next step is to set up our goals. As you'd imagine, you right click. You're given a number of options on what kind of goal we want to create. For this lesson, we want to create a surface goal to begin with. When I click my Flow and Simulation Analysis tab, it will bring up my simulation information above. So in the selection, I'm going to select my inlet volume flow. I want to display my volume flow rate. My first surface goal is complete. I'm now going to insert another surface goal to do with my flow simulation. I'm going to select all my static pressures, static pressure 1 to 5. You'll notice when I select all these, I'm given an option to create goal for each surface. If you tick this, it's much better off in the long run, so you can have different graphs and different plots. So again, I'm going to go for my volume flow rate and click yes. Next, I'm going to do an equation goal. Next, what I can do is rename these. I'm going to click and press F2 and it will open up. What I'm going to do is rename this inlet. So the SG stands for surface goal. I'm going to rename the inlet flow rate 1. I'm then going to rename the rest of them outlets, as we know that there are outlets. So I'm just going to go through them individually and rename them. You may think this is a bit of it takes a little bit of time, but if you come back and look at this in a few months' time, at least you'll know where you were at and what you did and what way you treated each face. Of course, I could have used Control C and Control V. We'll do that from now on, actually, to save a little bit of time. So Control C. Now that we have all our goals renamed, I can add in one more goal. I'm going to add in an equations goal. The best way to do this is to have your goals renamed so you can add them all. I'm going to try get the total flow rate. So I'm going to select all my outlet flow. I'm then going to tick yes, and I can, again, that's our equation goal. That's part 1 of this lesson. To find parts 2 and 3 of this lesson, please follow Solid Solutions Ireland on Twitter and on YouTube.